All right, are we ready to get started? All right. So now, chapter 15. Chapter 15 starts out really easy. You'll start daydreaming because it's so easy that you better come back. Okay. Put it up there, right there, just in case. I hope we can at least get started today, and then we'll talk about more. What we were going to do on Thursday was seasonal. Bless you. Bless you. Bless you. Are we recording? Take one. What really was supposed to happen on Thursday was seasonal indexing forecasting, which is very common. A lot of businesses do have seasons. So I hope you at least look over the PowerPoint, but we're probably not going to have time to do it because I want to spend at least the last 20 minutes on Thursday helping you prepare for the final, giving you a whole bunch of hints as to what not to study. You can start crossing off, say, okay, I'm not going to look at that, not going to look at that, not going to look at that. I'm going to give you at least one or two items from every chapter that you can cross it off and not have to worry about it, okay? If you're not here, it's not going to be on the recording. As you know, the recordings are just the stuff about the chapters. So get the notes from somebody if you're not here. Here's our first set of numbers. What you're looking at is the sales, probably in thousands or hundreds, whatever. Each week, anytime you have data, you're going to do forecasting, always put the data from the oldest piece of data to the most recent piece of data. Everybody hear that? Always. Do not accidentally flip that. Number one piece of data should always be the oldest piece of data. This should be the most recent. These are weeks, so here's your 10 weeks of data in order, from oldest to newest. It's especially important when we get to year, that order, because that order allows a lot more weight to put on the more recent data compared to the old data, as if maybe a trend could be happening. So it puts more weight on the trend that's taking place most recently. We're going to start out with moving average. Here's my information about moving average. It can be a 2-period moving average, 3-period, 4-period moving average, 5-period moving average, 10-period moving average, anything. And it's telling you to take the number of previous periods, 3-period moving average, 3, 4-period moving average, the previous 4. Add them together, divide by how many you just added, and find the average, and you're forecasting the next period. Now, here's the deal we're probably trying to forecast week 11, because that's the future. And that's the kind of information we want. And I want to point something out right now before I forget. If there's any accounting majors in here, this is one of the most important chapters for you because all budgeting starts with forecasts. You're forecasting overall revenue, you're forecasting departmental expenses. All budgets for the future are based on forecasts, and the technique you use to be able to have the closest forecast you can get to actual is so important to making your budgets a lot more accurate, so accounting majors. Meanwhile, we're trying to forecast, let's say, 11, 12, 13, something like that. So we would just jump in and use the previous, if it was a 3-period moving average, we would use period 8, 9, 10. But with all forecasting, you got to do as many forecasts as you can with taking into consideration the data you have here, so you can compare how the forecasting technique is doing compared to actuals, because you don't have actuals for the future yet. For example, if I said, take this data and find the 3-period moving average for every period you can compare to actual. Now let me state this again. 3-period moving average means the very first forecast you could do at all is the 4th period, because you're always using the previous periods to forecast the future. So a 3-period moving average, period 4 would be your first forecast. 5, 6, 7, 8, 9, and 10, because you can then compare your forecast to actual. All of these techniques, you've got to be able to compare your forecast to actual to see how it's doing. And that's how you select the best technique. And you reevaluate the techniques 6 months down the road. You'll go, it's been 6 months or a year. I got more forecast to do. I better check the technique I'm using compared to the new data we got. We got a whole year's worth of new data. And you're going to use past data. You keep using, and then you go on your spreadsheet and use different techniques, calculate how much error is involved, which is the big thing there, mean squared error, MSE. There's 3 or 4 different ones. This is my favorite, and we don't have enough time to learn them all. I'm going to point them out in the book for you, but that MSE is the one we're going to focus on for your final. You will for sure have to calculate which forecasting technique's better from one to the other based on that MSE. Now, I'm going to go on 3 moving average, but I know Chase had a question, I think Nick had a question. Go.
You will never try to predict the future on prior forecasts, always actual sales rate.
We actually are using prior forecasts when you use exponential smoothings, kind of. So that's there is some techniques you do use previous forecasts, and that's one.
Does the moving average have a correlation to like stocks and stuff in the forecasting with the max?
Does the moving average have correlations with the?
Yeah, stocks have the moving average like that.
Oh, a lot of stockbrokers will use moving average to try to predict which way the stock's going to go, so they can make their bets by saying, oh, that's going to go down. They'll short it then. Finance guys, short it. You borrow shares, you sell them real quick. Oh, the price went down. You buy back the shares and go, thank you for the loan, and you keep the profit. You pay a small fee for buying the shares. Yes, they use averages to try to forecast, but they'll try all kinds of techniques again. And again, that's a time series. All of these are kind of time series. Time's related to this. This represents that week's worth of a time unit. 125, I don't know if this is dollars or units. I'm jumping past the story here. Medicine past 10 weeks, this is sales. So shown on the next slide, 3-period moving average forecast. Doesn't say if the sales are in units, dollars, but it doesn't matter. It's all about the technique we're using. This could be anything. Now, if I said 3-period moving average, and I said, how does this technique compare to the actual data? And if you're going to compare another technique, you're going to say, okay, I got to start my forecast for every period I can do a forecast to compare to actual. 3-period moving average, 4th period is going to be your first forecast, and you'll have 1, 2, 3, 4, 5, 6, 7, whatever of them to use then to calculate your MSE. You tell me, 5-period moving average, where's your first forecast? 6. How many forecasts can you have compared to the previous data, to the actual? 5. So you'll have 1, 6, 7, 8, 9, and 10. You'll have 5 of them to compare, which is fine. One technique, you may have 7 to compare. Another technique, you may have 5 to compare. Another technique, you may have 9 to compare. It doesn't matter because you're going to turn them all into an MSE, and so you can compare apples to apples to apples, no matter how many forecasts you were able to use, and then you decide which one fits the data the best, and then you actually do forecast with that one only. No reason to do a whole bunch of forecasts. You're picking the one that fits, and you just use that one for a year, and then you reevaluate all the techniques, and you may use a different one for the following year to do all your budgets. Almost every business budgets out 5 years. Every business I've worked with and consulted with, 5 years in the future, rolling. Meaning, when a month goes by, you do your financials, you do your adjusted entries, you get to your final balance sheet, you're coming in on Monday, on the 1st of the next month, and you're extending your budget out a month now, because you always have 5 years of a plan in place. If this was a 2-period moving average, what period's our first forecast?
3.
And let's do our first forecast for period 3, 2-period moving average. What do I add together? Hang on, let me bring this up. Ready? Look at that. We're doing a 2-period moving average forecast. You just told me the first forecast is in period 3. You have to use however many periods before the forecast and find the average. So what am I doing? 110 plus 115 divided by 2. Our first forecast would be 112.5 for period 3. Now we'll add 115, 125 divided by 2. There's our forecast for period 4, and so on, and so on. Get it? Then we would find the difference between the forecast we just came up with and the actual, and again, and again, and then we square those differences. We'll stop there for there, and we'll pick up from there when we get to MSE. Here we go. Now we're doing another one. 3-period moving average. What's our first forecast? 4. How do I get it? 110 plus 115 plus 125 divided by? Oh, look at that. Hang on. backing up, plus 115 divided by 3. There's our forecast for period 4. Now we're doing period 5. We're going to use 120, 125, 115 divided by 3. There's period 5. We move to period 6. We're going to use 125, 120, 125 divided by 3. There's period 6. Everybody get this? Moving average is so easy. So easy. By the way, you also have a forecasting project coming up in your operations management, which is a supply chain management course that's required for all business majors. And a bunch of students have been contacting me from that course. This project you have at the end of the semester is where you have to find real data, and you have to say, you have to pick one of these techniques. You're going to learn these again, not so much the easy ones, but the harder ones you're going to hear again in operations. And you have to say, what if the data you found, real business data, what if it were forecasted using what's called a naive technique, which would be like, a naive technique would be where there's like no calculations involved. I think I'll use whatever the previous real sales were, and I'll use that as my forecast for the next period. So my forecast for period 2 would be 110. My forecast for period 3 would be 115. Notice, that's called naive forecasting because there's no real calculation involved. There's no formula. There's no statistical smoothing. You're just using the previous period. And then this assignment in this class you're going to have says, now use the same numbers using one of these sophisticated, real, not the moving average, but something more heavy-duty forecasting formula, maybe exponential smoothing, and calculate, you have to calculate not only the MSE, you have to calculate 2 other error formulas, and you got to then write up with what you discovered from a naive technique to a real technique. You got to write this up based on these MSE. Which one was fitting the data better? And that's your project. So it looks like there's about 3 people in each group. It's a big part of your grade. So you got to use a lot of data and make it big. One group of students sent it to me, and they were 7 spreadsheet pages. There's over 7 pages. You got to make this thing big. And that simulation project's even bigger than that. So I'm preparing you, trying to prepare you for this. So whatever you do when you get in operation, do not complain. Oh, we learned that already. Don't. Are you crazy? I'm only taking you a baby step into this. All right? I'm just getting you prepared. So don't complain. You're going to hear something twice. Be thankful. You know, good. Something I'm finally familiar with, and I'm not going to get lost. What's going to happen in operation? So now we're going to try something a little different. You can do a 3-period moving average. And by the way, write notes if you have the slides. Everybody gets confused because they don't see this. This is doing a 3-period moving average. So the first forecast looks like some period 3, but it really used these 3, divide by 3. That's period 4. T plus 1. That's 4s, that's 5, 6, 7, 8, 9, 10, and this is the future. So don't let this slide confuse you. You are forecasting a period into the one above the number you're using. All right. So now we're going to use the same data. We're moving to weighted moving average. Very much like moving average, except you need to apply weights to the previous numbers. For example, let's say I was going to tell you to do a 2-period, what's wrong with these? Weighted moving average, and let me think, 0.33, 0.34 and 0.66. Do I have that right? And then the sentence will say, apply these weights, 0.34 to the oldest piece of data, and 0.66 to the most recent. It'll say something like that. So, you ready? This is a 2-period moving average, weighted moving average, just like moving average. What's the first period you could do a forecast for to compare? 3. Because you can't do one for 1, it doesn't have 2 periods before it. 2, you don't have 2 periods, but 3 does. And every one of these after that has 2 periods before it. So to do this weighted average, very much like just a regular moving average, but instead of adding them and dividing, you just multiply each number by the respective weight that belongs there. We're doing period 3. We're supposed to apply 34%, they always add to 100, to the oldest one, which is period 1. So we would take 110 times 0.34 and get that number. We're going to apply the heavier weight to the more recent period, which is period 2. 115 times 0.66, get that number. And then we add those two numbers, and that's our forecast. Everybody see that?
So we're not dividing by anything?
That's right. We're not buying an average. We're applying weights, which turns this into a small number, 34% of it. This turns that into 66% of it, and when you add them together, it's like a number just like these. And it'll probably be between these. A little more weight there, so it's going to be closer. This should be about 114. Hunter, you all over this? 113.3? That's a little high. But as you notice, that's more towards the 115 than the 110 because we put more weight. Now, what would I do now for period 4? What's the shift that takes place? What periods am I using? Tell me what 34% times now. Yeah, you move down to 115. And the 0.66 now is multiplied times 125. Add them together, that's your forecast for period 4. This is pretty easy, so I hope you got it. I want to make sure you get this. I'm going to ask you to do a 3-period weighted moving average. And the weight will add up to 100%. And the story will say, use 0.25 for the oldest piece of data, and use 0.70 for the most recent. I'll make something like that. What am I at, 95? 0.055% for the middle piece of data. It gives you the weights. You apply the weights just like we did here, but this time it's a 3-period. The weights always add up to 100%. Did I blow it here? 70, 80, 95. Okay. They add up to 100%, but you now got to multiply 3 numbers times the appropriate weights and then add them together. So what would be the first period we could do a forecast to compare to an actual? That's right, period 4. So let's say we'll do period 4. I'm just going to keep switching to find one that works. Because I went to the closet and they're all gone for the semester. You ready? Period 4. All right, there's that closet. What do I multiply 110 by? Point what? 0.25, the oldest piece of data. Oh, is there more than 110? Period 1 is the oldest piece of data. Period 2, 115, so plus 115 times what? 0.05, the middle piece of data. And then plus 125 times 0.70, the most recent. I multiply those out, add them together, that's your forecast for period 4. Shift down. We're doing period 5 now. We'll make sure you have period 5. What number do I start with what was the first wave? 0.5, is that what it says? 0.2? So 0.2 times 0.25. That's what I saw. Thank you. Thought I saw 5. 0.25 times what? 115. You shifted down. Very good. Plus 0.05. 0.05 is the middle piece of data times 125 plus 0.70 times, what's the most recent piece of data? 120. And this is for period number 5. It's the 3 periods, this is a 3-period wind moving average, that precede whatever period it is you're doing a forecast for. So let's say we want to forecast, we decide to use this weighted total. We like these weights. We like the 0.25, the 0.05, and the 0.70. This fit our data better than any of the others. We're going to use it to forecast the future. Are you ready? Help me forecast period 11. Period 11, 0.25 times. Why 115? The 3 periods before what we're forecasting happen to be 115, 110, 130. And 0.25 is supposed to be multiplied by the oldest piece of data of those 3, which is the 115. Exactly. Here we go. Plus 0.05 times. 110, is that what it is? Thank you. Plus 0.70 times. 130. And there's our forecast for the future. We just went past the data we had. This is too easy, right? I want to make sure, though. Weighted moving average, 4-period, weighted moving average with the percentages in order from oldest that you apply to the oldest piece of data to the most recent, 0.25, 0.10, 0.60, they got 6, 7, 85, 95, 0.05 again. Right there. And this is already respectively in order from what you apply to the oldest to the most recent. I want to, this is a 4-period moving average, and I want you to help me forecast the future. Period 11. Now, you know what? What's the first period you would forecast in this situation if you were asked to do the MSE? What would be the first period you could forecast in this 4-period moving average? Period 5. Period 5 would be the first one you could use to compare it, because you can't forecast any of these because you've got to have at least 4 periods. Now, if you were going to do the future, period 11, what 4 periods would you use then to apply the weights?
7.
That's right. 7, 8, 9, and 10. What weight would be applied to this 110 right here if we're forecasting the future?
6.
The fourth one, the third one, 0.60. So it would be the first weight, second weight, third weight, the 0.05, that last weight would be here. You add them up, because you're multiplying, and that would be your forecast. Does everybody feel comfortable that they could do a moving average forecast, no matter if it's 2, 3, 4, or 5 period? And do you feel comfortable you can do a weighted moving forecast, whether it's 3, 2, 5 period, also, as long as you're given the weights and you know which weights belong to which previous periods? Everybody feel they can do that? These are pretty easy, right? Okay. Ready? Exponential smoothing. Same data. Same data. Exponential smoothing says, pick a smoothing constant between 0 and 1. And then you take that smoothing constant, and you're going to also find the opposite of the smoothing constant by subtracting it from 1. You ready? So if I have a smoothing constant of 0.3, what would be the opposite of the smoothing constant? 0.7. You get it. If I have a smoothing constant of 0.4, what would be the opposite? 0.6, right? They ought to add up to 1, the whole point here. Now, in exponential smoothing, you take your smoothing constant, I'm going to show you the work here, and you're always, in this case, the smoothing constant is 0.1, and you're multiplying it times the previous period's actual. Now, write notes there, because all it's there in the PowerPoint is a Y. So put here that this is the previous period's actual times the smoothing constant. The previous period's actual times the smoothing constant is the beginning. No matter what period we're forecasting, the words are the same. The previous period's actual times the smoothing constant. That's no matter which period that we're working on, the previous period's actual times the smoothing constant. Then you add to it the previous period's forecast. Chase, this is the one where we're using forecast. You use the previous period's forecast, so you've got to do these forecasts to work your way down, times the opposite of the smoothing constant. Everybody see that? So, I'm going to say, I want to make sure everybody gets this. Again, it's the smoothing constant times the previous period actual, plus the opposite of the smoothing constant times the previous period's forecast. The opposite of the smoothing constant times the previous period's forecast. And then you add them together, and that's your new forecast. You go down to the next one, same logic. The smoothing constant times the previous period actual, the opposite of the smoothing constant times the previous period forecast. You can't jump in this one down to 7 unless you have 6 finished, and 5, and 4, and 3, and 2, because they all build on each other. The only way to use previous period forecast is to do forecast for every period. You have this in Excel, though. It's just, you're doing the first one, you copy and paste. It goes really fast. But doing this by hand, you've got a lot of work to get to your real forecast now, because you can't do period 11 unless you have that right there, the previous period forecast, which is built on everything before it. How does exponential smoothing start? Exponential smoothing always starts with period 1's forecast always being period 1's actual with no calculation involved. Everybody hear that? Your forecast for period 1 exponential smoothing has no math involved. You just look at what the actual is, and that's the forecast. And Exponential smoothing is the only one where you never, ever, ever use the first period's forecast in your error calculations. And any of the error calculations, MSE, any of the others, you don't use period 1 if you're doing exponential smoothing, because there was no real calculating involved to get this forecast. You just looked and saw what the actual was. The only reason it's there is so that you can do a calculation for period 2, because you have to have a forecast from the previous period. So now we're going to do a real forecast, which is period 2, but with exponential smoothing, it's always whatever period 1 forecast is. So that gives a shortcut. Everybody hear that? And here's the math on it. No matter what this smoothing constant is, times the previous actual, which is 110, plus whatever the opposite of the smoothing constant is, times the previous forecast, which is 110, because you have to place there the previous actual, will always calculate out to whatever that is. These will always be the same number. If you want to just put scribbles across here, always the same number or something, you can just put it there. But this second one is used in the error calculations. You have to use this. It's really being calculated, but I'm just giving you a shortcut. Because it's always whatever the first forecast is. Okay, now, here we go. Period 3. Our smoothing constant is 0.1. We go look at what the actual is back at the original data and multiply it times 0.1. Period 2's actual was 115. Then the opposite, 0.9, times the previous forecast, which we just calculated here, 110. We add these together. Our forecast for period 3 is 110.5. Here we go to the next one. 0.1 times the previous actual. We go look at what 3's actual was. It was 125. The opposite, 0.9 times the previous forecast. We just calculated 110.5. Look what happens. The direction in which the numbers are going, the raw numbers are going, it smooths it out and just kind of gives you a slower kind of increase here going on, and that's what smoothing does. Now here's the deal. How do you know to use 0.1? That's the deal. With exponential smoothing, as you compare it to a moving average, a weighted moving average, trend projection, which we're going to get to, this exponential smoothing, you want to consider this. Say, I'm going to use a 0.1 smoothing constant. And then say, now I'm going to use a 0.9. Then do it again with a 0.3. Then do it again with a 0.7. And calculate MSE. When you get this all set up on Excel, it's just a matter of changing one little cell number, and the whole thing redoes for you, and it's not a lot of work. The first time that you put this on Excel, it's a lot of work. But just changing the smoothing constant, everything then follows. If you're using cell locations on everything. And you'll have an MSE. It will automatically calculate. Your Excel will give you the MSE. Okay, what if it's a 0.3 smoothing constant? There's an MSE. And all these times, you're getting the MSE, getting the MSE, getting the MSE, and you're trying to figure out which one fits best. It's whichever technique has the lowest MSE. That's the one that's fitting the data best. I want to repeat that. You have a question in your future where you're going to, here are these two techniques, and you're going to have to calculate the MSE and tell me which one's best. Whichever one calculates to the lowest MSE is the best technique. That's how you determine it. That's the work you're showing me. You're showing me some work, calculating that, you're doing some forecasts, you're finding the difference. You're doing another technique, find some forecasts, you're doing the difference. You calculate the MSE, which you're about to learn. You look at the two of them, you go, this one's lower, and the Ray sense says, this technique would be better because it has a lower MSE. Or circle it or do something that makes it obvious that's the one you're telling me it's better. Okay? Boy, this chapter seems easy. Here's an example now, trying to use a different smoothing constant. We did 0.1, we can see what happens, and now let's do 0.8. This one puts more weight on the previous actuals for each period than the forecast, where the one before was putting more weight on the previous forecast instead of the actuals. And let's see if this one fits better. This is like, even though this is exponential smoothing, it's almost like you're checking a whole other technique because you're using a completely different smoothing constant that is almost the other extreme in a way. So it should be a definite MSE significant since you're putting so much weight more on the actual here. Again, nothing changes on how you do exponential smoothing. The first forecast is the first actual, you throw it up there, and you do not include it in your MSE. The second forecast, if you want to do the math on it, but it will always be your first actual. The first forecast and the second forecast are the same. because the actual and the forecast are the same. So it doesn't matter which smoothing constant and opposite of smoothing constant. You're always going to get the same. Now, 0.8 times period 2's actual, which is 115. The opposite, 0.2 times the previous period's forecast, 110. There's period 3's forecast. Period 4. 0.8, we look up period 3's actual, it's 125. 0.2 times the previous forecast, 114. There's our new forecast. And so on and so on. And I want to make sure you're getting this, so I want you to help me do, we just found out this is the best one for fitting our data. So let's do an actual forecast now for next period, week, I guess, or year. Here, help me out here. Let's see, this is going to be forecast for period 11. This equals 0.8 times what? Does anybody know? Anybody got the PowerPoint? How do you know it's 130? It is, but I'm just wondering if anybody has it in front of them in writing, because he's just remembering it. Is it right where? All right. I'm gonna look at it. 130. All right, so 0.8 times 130 plus the opposite of 0.8, 0.2 times what? 111.53, because we're doing period 11. You're looking for the previous period's forecast, right there. This would be your first real forecast, because there's no actuals for period 11, and whatever this comes out to will be the number of what to expect for week 11, and whatever you were doing this for, to plan as to your raw materials, to plan on making sure your supplier has enough there, because this is how many you're going to sell. Whatever it is you're using this for, you now have the number to plan for next week. And if it's fitting the actual data better than the 0.1 smoothing constant was, I mean, it's pretty much going to lead you in the right direction. Now, MSE. This comparison you're about to see is comparing the smoothing constant of 0.1 to the smoothing constant of 0.8. But I want you to realize this could have been just comparing the smoothing constant of 0.8 to a weighted moving average with the same data. But the weighted moving average didn't have a forecast until period, let's say it's a 3-period moving average, the first forecast wasn't until period 4. Where this one, the first forecast is period 2. It doesn't matter. How many forecasts you have is what you divide by in the MSE calculation, so you have apples to apples. And it looks like this. Now, this is exponential smoothing with 0.1. This is that exponential smoothing with 0.8. Notice we don't have no forecast for period 1 here. And if we had weighted moving average right here, our first forecast would be lined up right here in period 4. We have 4, 5, 6, all the way to here. This one is dividing by 9 because we have 9 forecasts here. I'm sorry, 9 forecasts here that we're finding the difference of compared to the actual. Here's your actual. You ready? Our first forecast was 110. 115 minus 110 is 5. 5 squared. 125 minus 110.5 squared. 120 minus 111.95 squared. Everybody see where this is going? Even if this is weighted average, where's period 4? The actual for period 4 is 120 minus our period 4 forecast using weighted moving average, if we were using one, squared. But here, when we get to the end, here we're adding all the squares, dividing by, because we had 9 forecasts and 9 squares. But here, we would only have 7, I think. Is that right? 7 forecasts and 7 squares. So when we add all the squares together, we divide by 7. Now we have an MSE. Now we have an MSE. Now we have an MSE. If we were using exponential smoothing only, would you recommend that we use a 0.1 smoothing constant or a 0.8 smoothing constant? 0.8. Everybody see it? The 0.8 has a lower MSE compared to the 0.1. I want to make sure you see this. This is 115 minus 110 squared. 125 minus 114 squared. Actual minus this forecast squared. And then we have forecast here. Actual minus that forecast squared. And we could have another technique here. And another technique here. And they'll have different numbers of forecasts. So you've just got to make sure that you're dividing by the right number. This isn't one of those examples where you would use count. so that you always divide by however many cells have numbers in them above here. And it always will divide them by the right amount because it counts how many of these cells. If this were a count, it would count all the way from here to here. It sees that out of these 10 cells, there's 9, divides by 9. If you use count to look up here, it will count how many. We're using 3-period moving average, so it would, the first forecast is period 4, so it would count 7. It would divide by 7. And that way you're comparing apples to apples with these different techniques and figure out which one fits best. Okay, that's it for the easy stuff. How are we doing? We're okay? You're wondering what's going to get harder? You fell asleep?
No.
Okay, because I'm recording.
You can't record a couple of things.
Yeah. I'm going to turn it towards you. Okay. This is trend projection. My absolute favorite. This, in my particular experience, has 90% of the time been the one that fit the raw data the best when I've used in different situations. And I don't want you to let this formula intimidate you, because I'm going to break it down and show you just how easy this formula really is. You ready? All right. What is this? Here's our slope. Here's our, I call it the intercept. What do they call it? Trend line, projection, whatever. Intercept. That's the intercept. Okay? Slope. Get the slope first, because you got to use it within the intercept. The way to do trend projection is to form columns. Take your data, put it in order from oldest to most recent. So in this case, again, we're going to take this data right here. And we happen to have the months there. And we're going to put it in order from the oldest to the most recent, top to bottom. So the 353 would be period 1. 353. 2. Is it 387? Thank you. 387 and 3, dot, dot, dot. 3, 6. So we have 9 pieces of data. In the first column, you put the numbers from 1 to 9, representing how many pieces of data you have. Right next to it is the corresponding data, 353, 387, 342. Now, you add all of the numbers 1 through 9. 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. You just found the sum of whatever that is. And this happens to be, time. So this is going to be the sum of small t. The sum means use the sum of all those t's together. That's all that little symbol means. The sum of what? All those t's. Now, you add all of these actual data, the 353, the 387. And when you add these all up, you just found the sum of, does that look like a sum of? And this is probably y. So this will be the sum of y. Now I know you can see this back here. 1 through 9. Add them up. Now, if you have this slide written in front of you, write down the symbol, or just the words, sum of t. That is the sum of t. This one right here, are all the data added up, sum of y. Now this one, you go straight across. Take your t times the y and put it in the third column. 1 times 353, 2 times 387, 3 times 342. And what's happening here is you're applying weight to each of the actual data, and you're moving it over here, and you're going to have much more weight on the most recent data than you do the old data. If there's a trend taking place, you want that trend to be the biggest part of your forecast, the most recent information. So 9 times 408. You got all 9 of those, add them up. That is the sum of, this looks like this, sum of t, y. Because it's t times y, sum of t, y. That whole column. Okay, the last column. You take each one of these numbers you put here that represents the period, 1 through 9, and square it. 1 squared, 2 squared, 3 squared, 4 squared, 9 squared. and add them up. Add this up. You just found the sum of t squared. Now I want to review these because you have some problems possibly in your future where you're given, it will say sum of t squared equals 285. The sum of ty equals 17,844. The sum of y equals 3,480. The sum of t equals 45. Forecast period, blah, blah, blah. You may not have to put all of this together. You're already given these numbers right here. And then we go to the formula and plug them in. But who had a question? Somebody had a question.
I did, but I figured it out.
Oh. So, let's go back to this formula right here. You ready? Did I pass it? No, I didn't. And this is slightly different than your book formula, but it does the exact same thing. It just puts the n in a different place. They both do the same thing. N is the number of pieces of data you're using for this forecast. And if you recall, how many different pieces of data do we have? 9. So that's a 9. Sum of ty, that's not the sum of t times y. That's the sum of ty. The sum of ty was that third column over. You just put that number there. Whatever the sum was of that third column. Minus the sum of t. That was that first column over here, the sum of t. 9 plus 8 plus 7 plus 6 plus 5 plus 4. Times the sum of y. That was that second column where we added the 353, the 387, and all 9 of those. Gets placed right there. Now here's where everybody blows it. So I want to make sure everybody's done right notes and looks at this one. We got the numerator, right? This n is the number of piece data. The sum of ty is that third column. Minus the sum of t, the first column, times the sum of y, the second column. These are two different things here in the denominator. And I need to point this out because this is where this is one of those ones where I always say to you guys, no matter how much I'm making this clear, somebody always will do this. No matter everybody's listening to me right now, but someone will still do this. You ready? This says take n, again it was 9, multiply it times the sum of t squared. That was that very fourth column we just did. 1 squared, 2 squared, 3 squared, we add all the squares up. That's the sum of t squared, which is this one right here. This is not the sum of t squared. Somebody's going to use the same number right here. This is not the sum of t squared. This is the sum of t, the first column, then square it. The sum of t, long pause, squared. I don't know how else to tell you. Because there are two different numbers. Column 1, column 4. Right? And then that's it. You do the math. You got to multiply first up here. You got to multiply first there, then subtract. You got to multiply here, and then you got to square this, then subtract, then divide. You now have your slope. This could be positive, could be negative. The numbers are getting smaller, you'll get a negative slope. The numbers are getting larger through time, you'll have a positive slope. It's measuring the direction in which the numbers are building through time from period 1 to period 9, or however many periods you have. You've got to use the slope now to calculate the intercept, the b sub o, or when you're looking at period 0 is the way to look at it. And you've got to use the slope in this formula. These other two numbers right here, this stands for the mean or average of y. That one there is the average or mean of y. You would add up the sum of y, which you already have here, 353 plus 387 plus blah, 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 and then divide by the number of y's that you've added. I don't want to lose this formula. This number is the mean of the sum of t. The mean of t. You over here where you added 9 plus 8 plus 7 plus 6 plus 1, divide that number now by 9 to find the average. And that's what that is. So the average of y, the average of t. Multiply the average of t by the slope. Now be careful. This is a subtraction. We're heading to where you're going to use addition. But this one, for the intercept, that is subtraction. And if you have a negative slope, that means that's negative, subtracting negative times positive. So you're really going to end up adding Don't get it mixed up. This is a minus, and the slope could be negative. So that may turn into positive. Everybody understand what I'm trying to get at? This is negative. The next formula is going to almost look like this, but it's positive, it's added, and you could have a negative slope. So I want to make sure you get this. That's subtracting. The last one says your forecast, which looks like this, Y with a top hat on it means forecast, is going to be your intercept, which is B sub O, plus your slope, which is B sub 1, times whatever period number you're trying to forecast. All right. How are we doing on time? You doing okay? Everybody okay? All right, here we go. You ready? Here we go. We took all that data, we put it in order from 1 to 9, from oldest to newest. It looks like this. We added all our columns, sum of t, sum of y, multiply, then do not just multiply this and think that's going to equal that, because it won't. Then add these, square each of these, then add that. We're plugging all those numbers in to get our slope. And it looks like this. So here's the formula. We're plugging in 9 for n, the 17,844 for the sum of ty, 45 for the sum of t, 3480 for the sum of y, right? There's your numerator. Here is, and again, 9 pieces of data, the sum of t squared, that's that fourth column, minus the sum of t, the first column, squared, 45 squared. Subtract that, divide that. This data has a positive slope, 7.4. So each period is kind of increasing by about 7.4 as time's going on average. The intercept, where is this all going to start at? Sum of y, we added up all the y's, which was the 3480. There were 9 of those pieces of data, so we got the average right there. Then we take the average of t, 9 plus 8 plus 7 plus 6, divide by 9. The average would be the middle, basically 5. Put that there. Here's the slope. So it's the slope times the mean of t subtracted from the mean of y. There's our intercept. Our forecast is that intercept plus the slope, which could be negative, so be careful, plus the slope times whatever period number that would be on that list that you're trying to forecast. So let me tell you what I mean by list. If we're trying to forecast December, it would be period 10. But I want you to forecast February. You use the same equation. This is what I love about trying to forecast. You can go many periods in the future. The more you go, though, the less accurate it will most likely be. So you don't want to go too far. But I want to forecast February. So what would change? This doesn't change. That doesn't change. That does. What would that be? 12. 10 is December. 11 would be January. February would be 12. March would be 13. April would be 14. I would only go out usually maybe 6 periods. 12 at the max. I would never go 12 because I usually use years. 5 years maybe. And then I redo the whole thing and see if I have a new slope and a new intercept, and then I'll do more forecasts. But that's what's nice about it. I can forecast multiple periods instead of just one period once you have that slope and intercept. Now be careful. You may have a little problem in your future where it says, using trend projection forecasting with a slope of 7.4 and a B sub O intercept of 349.667, using 10 pieces of data with the data ending in November, monthly data ending in November, forecast April of next year. You're given everything you need. You're given this intercept, and you're given that slope. You know it's an add, unless that's a negative, but you know it's an add. And then you just got to figure out what period number I'm asking about. There was 9 pieces of data. I'm asking about April. 10 is December. 11 is January. 12 is February. 13 is March. So April will be 14. Is that correct? Did I count that right? Put a 14 there. You got April's forecast. It's that easy. The hard part is just getting the slope and intercept, and then you just plug in different numbers in. Okay, I just want to show you something just to kind of wet your whistle. See see this right here. This is where this company has data of selling ties, but they have seasons. So they broke their data into 3 seasons each year. Year 1, here's the 3 seasons, and here's their sales in dollars. Year 2, same seasons, and here's the sales. Year 3, year 4. What you're seeing here, we're going to learn what moving average, how to calculate, I'm sorry, not moving average, centered moving average. It's coming up on Thursday, I'll write it here. Centered moving average. Because you have to use centered moving average to get the season out of the data. And these are all centered moving averages here. These 3 added together, divide by 3, place it, shift down. Now it's these 3 added together, divide by 3, place it in the center, shift down. Now it's these 3 added together, divide by 3, place it, shift down. Get it? We'll talk about that more on Thursday. Once you have the centered moving averages, you got to take these centered moving averages and you got to pull out the ones for each of the same season. So season 3 has 1, 2, 3 of them. Is there a 4th? We'll pull the 3 out and put them together. There's more to it. Season, what did I start with? 3? Season 2 has 1, 2, 3, 4 of them. Pull out all 4 of them. Put them together. Matter of fact, you add them and find the average. Divide by 4. The first one, we're only adding 3 of them. Divide by 3. That was period 3. That's period 1. 1, 2, 3. Add those 3, divide by 3, and find the average. That's where I'll stop. What's happening is we then get to this step to find the seasonal index number. We then scale the actual data using the correct scale number, index number, and we take the season out of the data for every period. Now look at this data, how it just looks like regular data. You see how they're not far apart from each other? The seasons out of the data. We then take this data and treat it just like it's a time series, and we do our trend projection that we just learned. 1 through, how many we got here? 12. Remember this 1 through 12? There's your sum of t. 12 plus 11 plus 10 plus 9. Add all of these up. There's your sum of y. 1 times 1576, 2 times 1628, 3 times. There's your t times y. Add that up. Sum of ty. 1 squared, 2 squared, 3 squared, 12 squared. Add the squares up. There's your sum of t squared. You plug them all into that to find the slope now of this, to find the slope. You find the intercept. You forecast the next 3 seasons of the following year. But then, once you have these forecasts, you got to go work it backwards and put the season back in. And you'll have now these numbers that are more like this. The smallest number will be in period 3. The largest number will be in period 2, because you put the season back in after you did your forecast. That's what you've got to get to in real life if you ever encounter majors. If you're ever going to really use this in a business that has seasons, you got to know how to take the season out, do the trend projection you just learned, or whichever one fits best, because you're measuring how they fit when the season's out. Whichever ones fit best, use it for your forecast, then put the season back in for true forecast. So, and most businesses have seasons, so that's why that's so important.